During loading early morning the 8th of March 2007, motor vessel Repubblica di Genova capsized in the Belgian port of Antwerp. No injuries were reported. Eyewitnesses testified that the 215-meter-long vessel slowly rolled onto her starboard side while moored at the Verrebroek dock. Immediately after the incident, a contractor was instructed to remove the containers, which had fallen into the water. As the vessel had just been refueled, this had to be removed. In the meantime, an invitation to tender was sent to various salvers to plan the removal and recovery of the vessel. SVITZER Salvage wins the contract. SVITZER Salvage Master Paul van het Hof talks about the start of the operation.
SVITZER Salvage decided to design a plan to parbuckle the vessel with all the remaining cargo on board. After that, of course, the ship still had to be refloated, and thereby control of stability would be a huge challenge. The reason for parbuckling the vessel with all the remaining cargo on board would be that we would create minimal additional damage to the vessel. Together with our partner, we were able to design a very innovative pulling system in order to parbuckle this vessel and upright her again.
Upon awarding of the contract, system engineering was in full operation but not yet complete. It was calculated that in the worst-case scenario, a force of 7,000 metric tons would be required to parbuckle or right the vessel. To establish safe spread of forces over the hull to prevent damage, extensive calculations were required. Meanwhile, the salvage team continued its inspections to work out the detailed recovery plan. As a matter of contingency, an oil boom was positioned around the casualty.
Upon commencement of the operation, we knew that there was still 1,300 tons approximately of heavy fuel oil bunkers on board of the vessel. A very careful assessment concluded that most of the oil was still contained in the tanks, but there was one risk that oil would enter the forward pump room.
It was decided to drill a hole at the location of the pump room and inspect this compartment. During this inspection, oil was identified, and the decision was taken to remove it. To refloat the vessel after parbuckling, the stern ramp would have to be closed. Divers inspected the ramp to see if it had been deformed. To make sure the remains of the ramp would not deform and prevent closure, pieces were cut off by the divers and removed. To install the piles and wires to prevent the vessel from sliding during the parbuckling operation, all debris on the seabed between hull and quay wall had to be removed. To upright the vessel, the pull force was spread over 15 structures welded to the hull. Each had a 500-ton strand jack tensioner installed. In the original design, they were 5 meters high. However, ongoing calculations showed that the height would have to be increased to 10 meters to ensure optimal load distribution. The higher leverage required another installation procedure, and tower trucks were positioned on board to make the necessary attachments. Since cargo was still on board and partly above water, there was a risk that welding work on deck could cause a fire. To address this danger, a fire prevention system was installed. An external Fi-Fi pump pressurized a fire line fixed to the side of the vessel, and with the help of special nozzles, the weld spots were kept cool. Each anchor point on the seabed had to be able to sustain 500 tons of pull. Soil dynamics calculations showed that piles available on the market could sustain 250 metric tons. So, for each anchor point, 2 piles were required for the pulling machines. The steel piles were reinforced to handle the powerful forces. 38 of the heavy steel structures required to make their way through typical Dutch traffic. As the piles would be installed by a vibrating hammer, a new challenge emerged. The forces created on the internal pile welds during installation would be much higher than during parbuckling. Welds of 30 mm vertical height would be no exception. This meant so much extra work that delivery of the piles was delayed, which influenced operation planning. Calculations of the reinforced welds proved correct. During installation by the vibrating hammer, no difficulties were encountered. To prevent the vessel sliding sideways during parbuckling, it was necessary to install 8 wires running underneath the hull to the piles along the quay wall. The Salvers had chosen to use directional drilling technology to install the wires. So a drilling machine on the work barge first drilled a small tunnel underneath the stranded hull. As the drill head surfaced on the other side, the wire was connected. Recovery of the drill pipe brought the wire back under the hull. Connections of the wires to the drill pipe and positioning of the wire eye on the pile had to be done by divers in visibility conditions of less than 50 centimeters or 18 inches. The port authorities of Antwerp allowed installation of the piles in the port basin under the condition that the fairway between the piles and the opposite quay wall would be a minimum of 100 meters. Once the reaction wires used to prevent the vessel from a sideways slide were installed, the team continued with the installation of the pulling wires on the dock. The work barge then moved towards the piles in the basin to position a steel sling around each pile to be connected to a fiber rope. The team decided to use fiber ropes for the pulling system as they are relatively easy to handle, but especially because they don't twist once tensioned. However, they are sensitive to mechanical damage. The fiber ropes would not have to be pulled over the seabed during installation. It was required to keep a constant tension on the fiber rope reel once the barge began moving towards the casualty. The team installed a brake on the wheel, which was operated by the crane. The anchor head, the connection point of the pulling system, is lifted by the crane to the work barge. Now, on the deck of the work barge, the connection between the anchor head and the fiber rope can be made. Careful handling of the 48 small wires was essential. Altogether, they had to take a load of 500 tons. So all these small wires, the so-called strands, had to be adjusted to ensure they all had the same tension before commencement of the operation.
We had calculated that after parbuckling the vessel, there would be approximately 50,000 cubes of water inside the hull, which had to be pumped out in order to refloat the vessel. This requires an enormous amount of pump capacity. The team wanted to prevent shifting of the pumps during the refloating operation. And therefore, we wanted to install the pumps as low as possible in the vessel. We also knew that after parbuckling of the vessel, since the cargo decks were underwater, we could not reach this lowest point anymore. Therefore, the team had to invent an alternative solution to install the pumps prior to the parbuckling operation at the lowest position inside the vessel.
So a piping system was built on the side of the vessel and fed into the hull via the pilot door on the port side. Inside the hull, the pipes were laid over the cargo and via the various car decks towards the lowest deck where they were connected to the pipes. Now that the pulling wires were installed, equipment was removed from the hull and the strand jacks inspected before they would be tensioned to full load. Finally, each pulling system was tensioned to maximum load and the Salvers carefully checked all machinery, levers, hull and piles to identify any deformation or other incipient problems. The test program was completed without problems. On the early morning of the 31st of August, the team was ready to parbuckle the vessel. It was a beautiful, calm day, and conditions were excellent for the operation. The last inspections and final preparations were done before the gangway. Access to the hull for almost 4 months was removed. The last toolbox meeting and safety checks to make sure everybody was outside the danger zones, and the signal was given to commence the operation.
Iedereen die zich niet opzij hoeft te begeven uit de lijn van de trekmachines.
Het is uitgerekend dat hij met 400 ton, 410, 20 ton moet hij komen. De machines kunnen door tot 500 en als we de beveiliging overbruggen zelfs nog iets meer, maar dat zijn we toch echt niet van plan nu. We houden het systeem netjes bij met sensors, zodat we dus kunnen zien wat het schip doet.
Slowly, the vessel lifted her starboard side from the seabed. The team continuously monitored tension on the strand jacks and the behavior of the hull. Little by little, the starboard side of the vessel, underwater since the 8th of March, became visible. Nightfall sees the operation continuing. Almost midnight, the vessel was completely righted. A happy client.
We trusted SVITZER since the very beginning.
But careful inspection of the vessel's deck before any celebrations. Although the vessel was upright, the operation was not yet over. The challenge naturally also involved refloating. The team also had to solve the problem of stability during this critical part of the salvage operation. To lower the center of gravity to increase the stability of the vessel, it was decided to discharge the cargo from the upper decks before refloating. Inspection of the cargo decks showed what a mess capsizing had caused. Cranes, bobcats, winches and heavy trucks were used to separate the cargo and pull it to deck 9 for unloading. Finally, with all accessible cargo removed, a significant improvement in stability control. The team naturally had to prevent the vessel capsizing again during refloating. To do this, a barge had to be converted and positioned to starboard to control the list during refloating. The barge was rigged with 5 strand jacks of 250 tons capacity each. It was calculated that at least 1,000 tons lifting capacity would be necessary to maintain a list of less than 5 degrees throughout the refloat process. The former reaction wires, which prevented the vessel from sliding during parbuckling, were now used for lifting. The wires had to be pulled out of the sticky clay seabed. A challenge. A hydraulic vibrating hammer was used. Recovering the wires was time-consuming, but after 10 days all were recovered and lashed to the upper deck. Now they had to be prepared for their next task. Firstly, they were cut to the exact length to use them as pulling wires for the strand jacks. If they were too long, the strand jacks might not have been able to maintain stability during the last phase of the refloating operation. Once the wires were cut, a new socket was fixed to connect them to the strand jacks. To prevent the vessel suddenly rotating to port during refloating, the salvers connected 2 tackles between the barge and the vessel. Once the epoxy in the new sockets had hardened, the team was ready to connect the wires to the strand jacks on the barge. After the connections were made, each strand jack machine was tested to full tension. The wires in the hull were inspected by an ROV to make sure alignment was good.
The refloat operation was a very critical operation, and controlling stability was a major concern to the team. This type of vessel has car decks which run from fore to aft and from port to starboard. If during at any stage of the operation the water would suddenly move from one direction to another direction, we could have a situation which was not controllable anymore.
The team had worked out a system to close the cargo ramp, and on 12th September this was done. It was an exciting moment, as it was not sure if the ramp had been deformed during capsizing, which would mean the hull could not be made watertight without major reconstruction work. But the ramp closed perfectly, and as the pumps were started, the water level inside began to drop. Although the water level was dropping, tests showed that there was still a significant inward leakage of some 800 to 1,000 cubic meters an hour. The team then had to trace and patch all leaks. Their work reduced water ingress to some 150 cubic meters an hour. It was planned to refloat the vessel with an average list of 5 degrees to starboard with a maximum deviation of 2 degrees. It was calculated that it would take at least 24 hours to remove the bulk of water inside the vessel. The team had positioned a control room on board the vessel where trim, list, hogging and sagging were measured. The strand jacks were controlled from the same location, and tension on each of them was constantly available to the team. In the early morning of the 5th of October, the team was ready to commence the refloat operation. A last toolbox meeting summarized procedures, and the team took their positions over the vessel. Pumps starting at 6 o'clock announced operation start. Water from polluted locations was removed via an oil-water separator to prevent pollution of surface waters. Once the vessel was free of the seabed, tugs pushed her to the quay wall. Soundings inside and outside the vessel were taken continuously, and the information passed to the control room to update the stability control program. By working this way, the team was able to confirm its pre-refloating calculations had been correct and safety limits not exceeded.
We zijn aan het pompen sinds vanochtend 6 uur. Het gaat niet slecht. We hadden vanochtend even een probleem met een tank die niet mee wilde komen, de voorpiektank. Dat hebben we inmiddels het opgelost. We hebben eigenlijk de pompen vanaf 12 uur eventjes een stuk rustiger laten draaien. En nu gaan we het probleem proberen te compenseren en dan gaan we weer volle kracht verder. Maar het schip is inmiddels al volledig drijvende en hij hangt momenteel in de draden met een 800 ton. Dus dat is redelijk volgens het schema wat we in gedachten hadden.
It took until the 7th of October to remove the bulk of water and get the vessel so far out of the water that leakage stopped. Now the vessel had to be drained and discharged. One week after the start of the refloat operation, the team could finally lower the cargo ramp again to discharge the remaining cargo. It took a team of salvers 3 weeks to remove all the cargo from the remaining decks. Trucks, heavy bulldozers and containers. During cargo discharge, local shipping continued normally. Naturally, after the operation, all equipment and hardware had to be removed from the seabed and refurbished.
After 8 months of work, I think the team can look back on a very successful operation. The vessel was parbuckled with the cargo on board and refloated according to plan and finally delivered on the shipyard. And this all happened without pollution or any incident to our team members.
On the early morning of 18th of November, the Repubblica di Genova is ready to be moved to the shipyard. What people originally thought impossible had become reality thanks to the care, professionalism, invention and hard work of SVITZER Salvage specialists.